Good morning. How is everybody on this fine Tuesday? We're going to do some stretching exercises today, as in figuring out that stretch crate. So here we go. And hopefully we got everything set up. I got to kick the webcam settings on. There we go. Oh, it's a little darker today. All right. One's in the title too. Yes. They are. The personality's gonna be coming out after about a year and a half. So, and good morning, Xenocron. How are you? We're running using the new pipeline. So, for those of you that didn't know, yesterday built a tool that smooths out Starlink bumps for me. So I'm on the better than nothing beta, and live streaming doesn't do well with that. So those little, I guess they're like 5 to 10 second drops. So double check, make sure I'm not going to leak any secrets. Okay, here we go. So this is on my local machine. OBS is basically pushing packets to this process. You can see when the buffer grows. Right? And this thing is sending packets to this process, which is basically the same program. It is the wait for it program that we built yesterday. So that's receiving data, buffering it for n number of seconds. I think I have it set up for 30 seconds right now. And that's going, yeah, first day, first test. I was going to do it for 60, but 60 seemed really long. So we might have some bumps depending on Starlink. We'll see. But this should get rid of most of them. And that's sending to FFmpeg. So yeah, this local, this remote, this also remote. So FFmpeg is just sending data that it receives to Twitch, resulting in a very smooth output so far. So I'm going to be keeping an eye on that. Oh, you hooked up your private Elastic Stack to the project's AWS account because you hate sifting through logs. Oh, that's great. So far, pretty solid frame rate. No little alerts. Hey, let's click this button here. Notify me. Thank you, Twitch. I'm gonna take that back over to the other side. All right. Is that the reason behind the delay? Yes, that is the reason behind the delay. Right there, it's buffering. We just skipped a drop right there. So some buffering, whatever it could have been, we actually just avoided it. Could have been somebody around here uploading, a gigabyte of data or something. Good morning, Arxie. Good morning. That's it. We're going to go into Let's get the chat going. Yes, you can live with a 1 minute RTT. Yeah, I think it was actually hurting the VODs. It was hurting live because people would end up with more issues. So, and hopefully it's not just fully a minute. Let's see. Like for me, it says latency to broadcaster is 2.5 seconds, and that's plus, then you add 30 to that, so it's 32. This should be just over half a minute. But you can test it. You can say hello or whatever. Say hello to Capitan if Capitan's up. We're gonna test out some stuff. So let's go back into control. What we did in here might change. We'll have to see. Test module, test. Some Flexbox tests. That. Forgot to get the documentation going. And how was your Monday? Everybody survived Monday? I did. I was tired though. That daylight savings, that bit me hard. It's hard to wake up today too. Just dragging. Come on, Docs, you can do it. GD Native. It's just a huge set of docs. That, and I want to play with the async stuff that Toasthater put out there. That'd be fun. Oh, in Europe it's next week? I played Loop Hero last night, and you are hooked. I haven't seen Loop Hero. What? I've heard that it was kind of taken off on Steam. What is it? Loop Hero. It's a 2021 endless RPG developed by Russian studio Four Quarters. This one? I love the art. First thing they talk about, accessibility. That is gorgeous. Oh, round 2. This does look fun. It looks like a lot of fun. And I cannot scroll while it's like this. Like this little battle has to finish before I can go on with the page. Ah. Finally, the documentation saved us. $14, runs on everything. I might partake in that. Toss that on a tab over there. Okay. Did something a couple weeks ago that just messed up my upper back. All right, stretch. Gonna get our stretching exercises in. So, looking through stretch, and for me it seems like it's really made for many layers of Flexbox to be configured all in one go. So you basically have one Flexbox to rule them all, and then you add to that. So we might need to actually separate what happened earlier with Box and Flexbox. It'll eat my time? Well, it might be a good reward though. Like, hey, get your schoolwork done, you can play Loop Hero. 3 years later, they're still in the same grade. Actually, I think I'm going to stand today and adjust all this. Little adjustable cranky thing. I got this desk from some lumber store. It's like Home Depot or something. Just an adjustable workbench. No drawers, no nothing. Lift a couple 100 pounds up and down. It works great. It's a standing desk. Oops. There we go. So leaf nodes are meant to be things that know how to measure themselves. Oh, and I did find the documentation on this. So if you... This was different than any Rust Creative I've seen. So if you go to stretch... Okay, stretch. You go blah blah blah, blah blah blah, usage. Right. Nothing on here, just some very simple example that doesn't actually help you. Testing, relationship to yoga, all that, right? Apparently the guy used to work on yoga. Person, I don't know. What was it? Emil? Alright, but then you go to visly.app. No, this isn't it. Go to the repo. I'm trying to find it again. No, I've gone through this. Here. So in the About on the right, they have their GitHub pages linked. So if you happen to click on that link, that itty bitty little link in the corner of that, they have much better documentation. Right. Using Stretch, get in touch, yada yada. So we click on documentation here. You can switch between the kinds of which platform you want to use it on. And then inside of here, they actually have pretty good documentation. They don't list how they imagine this was supposed to be used, though. There's a link. Toss the link out there. Gotta resize some stuff over here. Is that scale? So far, Twitch Inspector says we're rosy. Alright, so in their example, they create a new node. This is the same Flexbox that's in browsers. Okay. Basically, this crate implements Flexbox if you're out of the browser. And if you read on their website why they did this, it's because they want the same layout to be used across platform. So if they're on Android, iOS, on the web, in some other app, they're using the same Flexbox implementation. And it's basically the same one. They compare it against Chrome. Right? So their unit tests actually compare against Chrome. Oh yeah, we've got Facecam. Where's... JavaScript outside of the browser? No. They're... The implementation of this is in Rust. And they export this, they make it available to JavaScript. So they're using the exact same Flexbox if they're in IE or Firefox, right? It's the same thing. If it runs WASM, actually, what's the NIUs for WASM? Yeah, there's no IE. So there's a pretty good support for WASM across the board. With there are little changes between these, between like Flexbox, Safari. But yeah, they use it like React Native. I think Visly, they've got some other sort of build apps, make it cross-platform, yada yada sort of thing going on. No handoff, no headaches. Musean. Did I miss a... Oh, hey! Welcome, Raiders. We are doing some stretching exercises today. Going to be using Stretch, this Flexbox setup, in Rust. How's your stream, Musean? What was the random project du jour? Flexbox Froggy. Oh, that's such a cool... This is a great way to learn Flexbox. It's just fantastic. We have a little bit of an exploration today. Due to my switch over to Starlink, I had to build a little buffering tool. And so we've actually got a 30-second buffer that is not, that Twitch is not aware of. So OBS is exporting to this program, which we wrote yesterday, which then sends it across the network to something that's closer to Twitch. And then that gets fed into FFmpeg, and that speeds it, sends it off to Twitch. Oh, you decided to add... Oh, interesting. A replacement / message rewriting configuration language thing. So what would that do? Oh, interesting. Custom bespoke messages. That's neat. That's really cool. Oh, that's funny. Well, let me know when you have it at a stable point, and we'll test it out. Trying to keep an eye on this other stuff. So far, so good. Let me see. I'll show you what Starlink shows us. So where's OBS? Come on, load up. I like the slowest Android phone. No, I don't. My wife's phone is so much faster than mine. All right, so basically at the top here, we got, you can see the cracks in the screen, but up here you can see the pings. Occasionally they'll drop, like we had a drop way back over there. Oh, having one right now. You can see that there. Uh-oh. Might actually buffer out here. That was a long one. I think we probably hit 0. This is why it's going to double the buffer. So I think that one probably causes buffering issues. So once this comes back, buffer drains, we should be able to get, yeah, see, we hit 0 packets for a little bit. What was that? 1, 2, 3, 7 seconds, which means that the speed on this should have dropped. looks like it's recovered. Wow. Rough couple moments there. So, oh, but only a very small speed drop here. So you might not have noticed, thanks to the software. And 30 seconds was just on the edge of that. Wow. Little replacement language, as you envisioned it midstream. Oh, nice. That's cool. So you just have the link instead here. Oh, I see. No, this is the match. This is the right-hand side where you can use these elements inside of here. This is the whole match. Got it. Got it. That's cool. That's really cool. Nice. And is that already in? Patterns are just regular expressions. Speaking, sorry. Regular expressions. Already up to date. Oh, not there yet. Nice. All right. Well, I'll definitely check it out. Uh-oh. Gotcha. Writing a parser. Oh, we got another drop. This is also an experiment stream, right? Seeing how this is doing. Seems like it's holding up pretty well. Even that big drop that we had where packets went to 0 in all the buffers, that didn't actually trigger a Twitch notification. Today was your first day off in like 10 days, and it's raining. Oh no. It's going to replace the fence, but it's super soaked outside, so you decided to stream instead. Well, that should soften the ground for tomorrow. Make it nice and easy to dig tomorrow. go here. I gotcha. I gotcha. Nodes can be mutated, and Stretch will automatically recompute only the subtrees which have changed. You're busy until like April? Sounds like a tax gig. Oh, your second or third free day of this month. Wow. Do you do more like contract stuff or like full time? If you mind sharing. No, that's okay. Replaces the children of an existing node. So we're gonna have to figure out how to wire this back into Godot. Because we're not doing this quite right. Oh, you stopped being a professional programmer. Oh. That's cool. I feel like I would still program like you're doing. Oh, we built some macros that need to be dried up a bit, but they're okay. All right, so how do we get Flexbox to work with this? So we're going to have Godot nodes, right? And Godot has its own scene tree. And how do we squeeze Godot into Stretch? That's the challenge. More than Soma 5209. Stretch wants one instance for a layout, because I can see us having multiple instances of Stretch in Godot, in a scene somewhere in Godot, right? Maybe you have like a control panel over here and it's all laid out cool in 3D space, and you turn around and you see another one. Get away, chair. Get away, chair. I've seen that cassowary exist. That's the one that's used in Apple. Like a lot of Apple UI uses it. I just need it for constraint solving. I think I was also going to use, well, I understand Flexbox, and I guess it is really just constraint solving that we're trying to do. Let's take a peek. Updated over 3 years ago. Does it have dependencies? Oh, it has no dependencies. Okay. Cassowary is designed for solving constraints to layout user interfaces. Constraints typically take the form of this button must line up with this text box, or this box should try to be 3 times the size of this other box. The most popular incarnation by far is Apple's auto layout system on Mac OS X and iOS user interfaces. Read the documentation. Alright. Oh, they have their own docs that they set up on GitHub pages too. Constraint solving. This script aims to provide syntax for describing linear constraints as naturally as possible within the limitations of Rust type system. Generally, you can write constraints as you would naturally. However, the operator symbol, or greater than, less than, equals, is replaced with an instance of the weighted relation enum wrapped in pipe brackets. For example, the constraint a plus b times 2 plus c is greater than or equal to d plus 1. Strength s. Okay. The code to use is... Oh, interesting. That feels like such... Is that a... I mean, that looks like a closure. It must be a closure. A simple example. Imagine a layout consisting of 2 elements laid out horizontally. For a small window widths, the elements should compress to fit, but if there's enough space, they should display their preferred widths. First element will align to the left, the second to the right. Okay. Oh, it's overloading the bit or operator. Oh, interesting. I see. Fancy. Alright, this is just print the changes, that's fine. Define the variable required. I mean, that looks fairly straightforward. Constraint solver. Add constraints. Window width. I'm just doing the width, right? Left line. Positive window width. Oh, I see. So they're saying that the window width, this must always be greater than 0, or greater than or equal to 0. The window width is currently free to take any positive values. See, it's most efficient to use an edit variable instead of repeatedly removing and adding constraints. Note that for efficiency reasons, we cannot edit a normal constraint that has been added to the solver. I want to see what this is. Oh man, I was trying to use was it GStreamer? A couple streams back. That syntax is hard to parse. They just use pipe for everything. Or not pipe, exclamation mark. That is just crazy. How stable has the stream been so far? Looks like we've had some issues, but Twitch Inspector is still fine. Alright. The window width is currently free to take any positive value. Okay, yeah, we read that. Add edit variable. Window width, strong, unwrap, okay. Suggest value. Oh, interesting. So you just fetch the changes. Oh, wow. So, oh, I see it. So you're naming variables, giving them constraints. These are instances of variable, so it can inspect them, know what is what. Uh-oh. Instability. It just hit. Yeah, it started buffering quite a bit. Still climbing? No. Wow, this is quite a choppy session here. Who knows if this will make it out, but looks like it's doing some uploading. You can see here, we're printing out that stuff. It's not part of the API. Let's see. There. You can see here, we just had a bunch of chatter on the side here. I don't know, it's not clear, but you get the idea. There's some lines going up and down over there. And it recovered. Alright, well that's a good test today. I think tomorrow I will double the buffer time just to see. All Caraway has is basically variables, constraints, and the solver. Gotcha. In a user interface, this is not likely the result we would prefer. The solution is to add another constraint to control the behavior when the preferred widths cannot both be satisfied. Okay. And what are the constraints that you can add? Is it constraints? Actually, I want to see what variable has. Variable? It's just a variable. Each new variable is unique in the view of the solver, but copying or cloning the variable produces a copy of the same variable. Oh, interesting. So they're the exact same variable if you clone it. Say like these two things have exactly the same variable. All right. Solver. And constraint. Let's go back one. Add edit variable. Fetch changes. Okay. Hey, good morning. Morning, Raiders. Welcome. Welcome. Victorov, how was your stream? What were you working on? I do a little snooping. I've got a little delay going on today. We're trying to battle a packet loss that I get occasionally from Starlink. So we've got our buffer set up. We wrote some software on the stream the other day to set this up. And it smooths out most things. The only downside is until Starlink is better than nothing, then we're gonna have this. Oh, nice. You finished your SSR improvements to your game engine. What are we working on? We're investigating layout and constraint solvers. It's basically Stretch, which does Flexbox for Rust. And then there's also Cassowary. We might lean towards Cassowary. Just need to figure out. So we're building a small game using Godot and Rust using GD Native. But I want to have these 2D interfaces in 3D space. And I want a layout engine for that. So we've ended up creating, let's see, tessellated fonts in 3D space, some boxes and rectangles and things like that that have rounded and curved corners for kind of clean UI layouts. How stable is it now? These are printed out once a second. So it's pretty good. We had a blop there. Then earlier we went pretty bad, actually. We had an unstable event on Twitch. So we've had one. And that large one up there, scrolling back down, lasted for I don't know, 45 seconds or so. But it wasn't like one just drop. It was actually a sequence of bad drops. But when that did happen, the speed didn't actually change for very long, which is usually what happens. I'll see it like right there. See that speed? It dropped for a bit, then it came back. And that's usually when you you would see the buffering on your side. But it didn't drop very low, so you might not have noticed. You might have just chewed through your buffer a little bit. Let's go back down. Alright, so we defined variables. Weighted relation. Alright, let's look at that. This is part of the syntactic tree used for specifying constraints. This enum should be used as part of a constraint expression. Equal, less than or equal, greater than or equal. Gotcha. And these are just the variables, right? So if you had some, like a bunch of boxes stacked, we just solve for that. At the start of your stream, you had pleasing numbers. Almost didn't even start because of it, so it wouldn't change. You basically define a constraint, and it solves them, and you can get values, get the variables, new values. Okay, that's cool. Okay, I want to read it again. I see. So this is the variable. This is the constraint. So 2-column layout. A divided by 2 plus B divided by 2 is greater than or equal to width. Gotcha. Huh. That's neat. That's really neat. And what are these required bits? See, it's weak. Preferred widths, required widths. Oh, it's required that it's greater than or equal to this. It's equal, but I thought these... I mean, we were looking at that, and this F64 was weak. Strength, that's in strength. Modules, strength. Medium, required, strong, and weak. I love it. And you streamed? No. That is just like perfect. That's very cool. All right, so let's play around with Cassowary for a bit. I get the constraint solver. I'm just trying to figure out how to wire this into Godot, right? Because Godot has these things that can come and go at runtime. And we'll have these events where some UI element might get added to the scene, which means that it gets the onEntered tree event. Then it needs to emit some sort of signal that goes and registers with something. And that something would be holding on to Cassowary. And Cassowary would then feed into its constraint solver whatever the constraints were that module needed in relation to where it is in the graph. It's either that or we have many of these and they kind of bubble up, right? Like maybe we have something. Maybe we have something that they can basically take. We have local constraints in a local constraint solver. Let's say we had like a V box and an H box. The solver itself is not send and not sync. That should be okay. It should be okay. So we're not using any threading on the Godot side, so all of the functions that get called should be called from the same thread. So that's where should we have multiple instances? Let's say we're building some sort of layout, and the one I have in my mind at the moment, I will draw. Say new file. There. Basically, get our chalk out. We have some UI, right? And there might be a box up here as a title or something. And then we have a number of elements inside of here. So this would be like a V box, vertical box. And this one might actually scroll. You might be able to fling this up and down. Then we would have something else at the bottom, H box, with some buttons down here. So we might be able to have this one here. Yeah, we could use Cassowary in a much smaller way, couldn't we? And we have this one. And then the whole thing itself. Yeah, because what about this, the outer one? Basically that V box again. Because that green one would say, hey, this one at the top, you get as much space as you need. The one at the bottom, you get as much space as you need vertically. But the one in the middle, you get all the extra space. You get what's remaining. That one seems like the most complicated piece here. But that just seems like a couple of variables, and then this gets whatever's left over. And then if this changes, then we can tell the inner one, hey, this is your constraint. Let's try it. I think the answer to this is yes. It's going to be parent-child sort of relationship, which is what we were trying to do before. Just silencing the Rust analyzer. Alright, but this is called Flexbox now, and it's got all these different properties, which we are fine getting rid of. Now, what does this control? I also have the box drawer. Is it the same thing? The border drawing tool. It might be. All right. I think we have the Flexbox drawing bits all commented out, don't we? Where is it? Layout, yada yada. Yeah, here, render. That's all commented out. Yeah, we're gonna leave that commented out for now. Let's create. What do we call this new tool? And how do we have something be a child and a parent at the same time? Because we will need constraints. But how do we wire them in? The parent is doing the solving. The children have to register themselves. And it's that relationship. So the parent has to be a certain kind of thing. So let's say we did a VBox. Right, the outer box here. It's a VBox. Oh, sorry, got a message. So if we had a VBox, that's not a box, that's a poorly drawn line. It's art. That's right, it's art. You've been trying to teach me this. So we have that. Now let's say we wanted a border in there. That could be a child. So the green one's a parent. We could have a special child, which is its border. Maybe we just call it border, maybe it's something else. Oh, hold on, work thing. Just 1 minute. So we can have one special thing that knows how to draw the shape of the box itself. Then we could have each individual child, but the child's going to have to tell the parent that it exists, which we can do through onEnterTree. When that happens, it's going to have to provide the parent with some, I guess, set of constraints. Because if this is a text element, let's say this is text, right? So we're gonna have these little boxes with text in them. Here's our text, right? The problem with text is that it might actually, by changing the width, it might change the height. So how do we get that to work in Cassowary? Because we don't know the height until the width is given to us. This being a VBox, it probably has a known width. Right, the width is known. The height is known here. It's just how much space is given to each one that is unknown. So when the child talks to the parent, it could give information and get information back. Or you could just say, hey, register me, tell me what my constraints currently are. What are the dimensions? So it could get dimensions back. Or whatever the fixed things are, like we saw with Flexbox, right? It says, hey, the height, unknown. This is an HBox. Or excuse me, a VBox. This is a VBox. Height's unknown. The width is fixed though. We only have so much width. Then this would know how to calculate its height, because it would have a fixed width. You could do the line wrap, word wrap, calculate its width and height, and then send those constraints back up. Work thing again. Yeah, this is early for me before work, but I have a colleague that is on the other coast and he's got some issues. Just a couple more moments. Dun, dun, dun. All right. Then a Flexbox would be easiest. Where each sub-element could be another Flexbox. I was thinking about that too, and that's what we had implemented, but it's not quite right. Flexbox, the implementation appears to be set up so that you're doing it, quote-unquote, the right way with Flexbox or Stretch, that you end up creating a tree that exists within Flux, within Stretch. So Druid's Fluxbox is a pretty nice API. I mean, realistically, what we're looking for right here is something we could probably build out pretty simple. It's a HBox and VBox and HBox. For me, it's just trying to tie it to Godot. Because we need something that can kind of scan the tree, ask it about everything, and then solve it. Which isn't a bad way to go. Actually. Hold on, let's investigate that just a little bit. So this is local. Let's go into GD native. We can't go in there. They don't have signals in there. We must start with Godot. Well, that's an old. See, that's how you leak secrets right there. Yeah, that's an old one. All right. Just in case, I reset it. Where's Godot? Yeah, that's right. Godot. Applications. I'm. Solve it. All right. So this is what we've built out so far. First box, second box, third box, fourth box. You can see that they're actually overlaying. So it didn't work right. Okay, I think we could have gotten through it. But I like the idea of Cassowary more than I do the other. So, but here we have a text element, right? And the text element is going to need to know what its width constraint is in order to provide a height constraint. If we had an image, the image would know its width and height. So I think text is probably the harder one, right? Because it doesn't know what its height is. Actually, yeah, because given a width, it then has a height. And we have certain events, right? So when text gets added to the scene graph here, you can do certain things. They can call parent, etc. You can go up multiple parents. But I think we just want to find the closest one that you can register with. I like the idea of having, I'm just going to add some stuff and name them. Say spatial, say this is some solver. And then we have some sort of renderer for the solver. Like, what does a solver actually look like? This is the solver UI. Right, but the solver itself has other children. Let's say here we had some other sort of box. And these could be flipped, right? And this could be text. This could be some sort of VBox solver, its UI, and then this could get duplicated. So we have the different boxes there, and the text elements inside of that. The box was just going to be a pass-through. But if we did flip these, because we might actually need the box. The box has padding, it has margin. So the text needs to then have that subtracted from it. I gotta say, this thing is just constantly sitting in the back of my mind. And I'm glad that it kind of worked with this 30-second buffer. While it's not the greatest, definitely smoothed things out. We would have had many, many, many more issues. Box seems fine, right? It's just subtract some things when it passes information through. But we do need some sort of interface. And it needs to be simple enough that we can pass it through Godot's Signal API. I could not think of another way to be able to know exactly what the class type was for the parent through Godot. And we could get its class name. Where is it? Go to script. Search help. Get class. Returns the object's class as a string. So it could tell that, hey, you are a VBox, or you are an HBox, etc., etc. That's great. The problem was solved at work by deleting the source folder. We use Webpack at work and JavaScript. And oh my goodness. I do miss Rust over there. So, I don't want to use this get class. It's just so hacky. Signals are a great way to go, because we can just say, hey, do you have the signal? If so, I'm going to send you this data. And that works out pretty well. Alright, but I still don't have a good... Okay, we did identify the box though. Okay, a box. Box. What are the properties of the box? Passes through. Passes. Yeah. As a child. Element. Held element size is box size minus. What is it? The margin. Margin padding. Oops, knock that down. I have text element. Let's say we also have a V box. With multiple children. As fixed width. And optionally scroll. Let's put that in the wish list section. I think I have spell checking turned on. Layout is going to be a V box. Box. The text. And this might happen multiple times. This part. So if we did have 3 elements, because 3 is more than 2. What would the flow be? VBox is added to the scene. It needs to know what its width and height is. And what is its playground? Is that always going to work? But it's either this, or we have solver at the top that all this gets aggregated up into. Text is still the one that gets me. So let's pretend that we had some sort of solver at the top. Okay. Got the VBox, got the box, got the text. When something like this got passed up, it's like each one of these would have to just propagate it up, maybe change it a little bit. Let's go back to Caroline. I see. That's just to be able to print it. So we don't need that stuff. Basically, we just have elements. Well, we have variables. We have variables and constraints. So a VBox could then look at its children and say, hey, your width is this. And this could go through and solve it. Well, it would have like 5 or 10 elements, right? Positive widths. Oh, box 2.left is less than box 1.right. What do you call a mosquito without wings? I don't know what. What do you call a mosquito without wings, Musi? That's funny. Oh, the delay. It's killing me. Tommy Luco, good morning. An hitchhiker. Solver's added to the scene. Oh, my raid glitched out yesterday. Did it? Oh, that's too bad. No spell effect. Alright, what happens when VBox gets added to the scene? VBox needs to swimming with sharks is an expensive hobby. It can cost an arm and a leg. Let's see, at this point it registers itself with its parent. And when it does that, what does it say? Does it say, hey, I'm a VBox, welcome? Or does it give information? Does it just tell it about itself? Likes moonlit walks on the shore, crashing waves. What else does it do? Let's see, parent is a solver. The solver welcomes the VBox. Right. But what does that mean? It just basically adds a constraint? Does it add variables at this point? Because changes, so we fetch changes from the solver, we actually need to know how to tell the individual components that their variables change. A platypus orders something from a duck. A duck-billed platypus. That's a good one. All right. So we get the changes. It's a variable in an F64. But the solver needs to know who does this variable belong to. So we'll have to store a reference to that. So the VBox is going to have to pass its variables off, right? Registers its variables with the parent. You love your job, you're so happy. My music just fits right into your mood. Oh, that's awesome. That's awesome. I'm glad you like your job. For me, it like comes and goes in waves. And I'm in one of those kind of down elements right now. Sometimes it's good, sometimes it's bad. Good and bad. It's just so binary. It's not binary. But I spent like, was it 2 hours trying to style some material UI component last night. Just soul crushing. You should have left Apple years ago. You had a dream that you were crossing a very wide river. It was like a fairy tale. Oh, that's great. That's great. Oh, nice. Yeah, that's where I am too. I'm not a VMware, but you know, as long as I get my stuff done, they leave me alone. I gotta say, I would rather be doing Rust at work than JavaScript. I mean, at work, you end up with something like, just some, function bar, right? Have something, and you'll deconstruct, and somebody will have like, props, but it gets spelled wrong, right? And then you try to do something where you're referencing it in here, const who equals bar, and that all works. But then you call bar, and you pass a baz in. It doesn't tell you. It doesn't care. It doesn't care that baz doesn't have a porps. That baz only has props. Friends wanted to name our band Duvet, but we're not a cover band. Basically help out other people where they went off the path and fix their problems. That's cool. Basically the solver. Come in and solve the problems. Alright. So I like this idea here where we have things like a solver, we have a VBox. The solver gets basically some constraints and variables from these elements themselves. So like a VBox, what's it going to do? Does it even have? Let's see, add constraint, new solvers.